Alright, we're on the Advanced 4 lesson, Number Concepts 2, and the first thing we're going to talk about is exponents. So here are different rules for exponents. Any number to the first power is that same number. X to the 0 is 1 as long as x is not 0. If you have a base raised to a negative exponent, you can reciprocate the base, and that makes the exponent positive. The product rule says that if you're multiplying the same bases, you are to add the exponents. Quotient rule says if you are dividing with the same base, x in this case, subtract the exponents, top minus bottom. The power rule says that if you have an exponent to an exponent, you multiply the exponents. The product power rule says that if you are multiplying two different things together, and that in turn is raised to an exponent, you multiply the exponent on the outside times each exponent on the inside. Quotient power rule is very similar. If you have a fraction raised to an exponent, you can apply the exponent to both the numerator and denominator. Let's look at the first example. Remember, these are advanced problems, so some of these things it's better for us just to cheat than to actually do the math because we are being graded on time. This one we can do with math quicker probably than cheating. If 9 to the x equals 3, then what is 9 to the 4x? Well, if I take and write this equation down, and I want to manipulate it so it looks like this, 9 to the 4x. Well, how can I multiply a 4 times the exponent? That's if I raise both powers to the fourth power. Power to a power property says an exponent to an exponent, you multiply them. Now we got this 4x on the left. On the right, 3 to the fourth means 3 times 3 times 3 times 3, which is 81. Therefore, 9 to the 4x is equal to 81. This next problem, I worked out on my paper. It took me 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. And then when I was finished, I thought this would probably be much faster if I would just plug this into my calculator. Here's what I mean. If I plug 2 square roots of 2 into my calculator, that's this right side, it's about 2.8. Since we have these answers already down here, if we take and plug each of these in for n, so it would be like a 1 to the 16th in parentheses, caret in your calculator, negative 3 divided by 2 minus 1, this has to be in parentheses, you will find that ends up being 1,024. Not the right answer. If you plug in negative 5/8, this one here is going to give us 90.5. Also not the right answer. If you plug in answer D, it's going to give you the correct answer of 2.8. So that's the correct answer. What I'm saying is, yes, there's an algebraic way to do this problem, but it takes too long. This problem is much faster. Once again, I circled something that wasn't the correct answer. This problem works out much faster if you just plug each answer in for n until it equals what the right side was, which was about 2.8. If you want to know the algebra, come back to my desk and I will show you. It's a wonderful algebra. It's just difficult to do it quickly when you're taking the ACT. Number 3, if x is a positive number, so that 3 to the times 8 to the 5x equals 6 times 2 to the 9x plus 3, what is the value of x? This problem, once again, is done much faster if you plug it into your calculator. How I would do this one in my calculator, since both sides have a variable in it, I would subtract this from both sides, so we get 3 times 8 to the 5x minus 6 times 2 equals, 6 times 2 to the 9x plus 3 equals 0. And then I would plug this left side into your calculator, each time using one of the numbers in the answers. And whichever one gives you 0 for the answer, then that's going to be the correct answer. And this one turns out to be answer F is the one that works. Scratch that. That's not true. It's answer H. That's the one that works. Once again, you can do it using algebra, and I can show you if you want me to show you. I'd be happy to, but it's much faster if you just plug in the answers to the equation. Lovely.